Welcome to today's webinar. In this webinar, we'll be talking about how to enhance your application using NLP, and the service that of choice here would be Amazon Comprehend. My name is Pratap Ramamurthy. I'm a partner solutions architect. I help partners, especially machine learning partners, build on top of AWS. I work with partners like Domino Data Labs and H2O and the likes. For today's webinar, I'm going to be showing you how to enhance an application. And the application that I chose today is called the Voice of the Customer application, or in short form, it's called VOC. The reason I chose this application is that this is the poster boy of NLP, right? This is an application which uses a lot of natural language, text, that customers provide. So it's one of the best examples of applications that can be enhanced quite a bit using natural language processing. So that is the choice I made, but you can easily apply the lessons that we learn here or the architectural designs that we hear to your application that has natural language in it. All right, what is VOC and how is it usually architected? So let me first explain what a VOC does. A VOC is an internal tool that is an internal application, internal to an enterprise, where folks who manage products look at the feedback that the customer has provided about their products or services. And so that's why it's called the voice of the customer, as in what the customers are saying. And the way in which it usually works is it collects, the first step would be to collect the information. The information could be internal sources, like it could be emails, chats, transcripts. It could be tickets like Jira tickets or support tickets, or it could be surveys that we ran. It could also contain external sources, like you could be getting feeds from social media, it could be forums, it could also be direct customer reviews, like the feedback form that customers usually fill out. Right. So that is the first step, first stage in a VOC application, to collect all the information that you require to analyze. Once you have collected that information, the application, what it does is processing or transformation, because the raw data is not amenable to viewing. We need to first run these natural language processing algorithms on them to identify possibly to have a sentiment score on the text that the customer has provided. You could also combine this with other data that you have. Possibly, let's say if you have a CRM system in-house, you may want to join the customer's data with the customer ID that you have in your CRM system and merge these things or do a join. You could run classification algorithms to identify what kinds of products are they talking about. And finally, what you do is you insert all the processed data into a data store or database. Once that is done, what you need to do is the third step of the application is to store this or display this, so deliver this data, this rich data, in the form of a reports or validation reports. The validation reports is usually seen by executives or top-level management to understand how the customers are feeling about their products. This could also be used for discovery or exploration. Let's say you are a product manager and you are trying to understand and discover new patterns in customer feedback in usage, or you're trying to understand some new trends. You could use this tool to explore. And a third important use case could be that you want to detect some important events. Possibly there has been an event and let's say the social media is buzzing with these new comments about your service or product, either positive or negative, and you want to detect this. So this application could be used for detection as well. Right, so this is what a VOC application or voice of the customer application is. right? Before I enhance this architecture, VOC application architecture, I want to first have a baseline architecture, and the baseline architecture I'm going to be using is it's called a serverless architecture. A serverless architecture is very simple to understand. It is an application which does not use servers or instances. Like in this architecture, you would stop using, you would not have to understand or guess the number of instances that you would use, the type of instances that you use, and so on. But use serverless services and make things much more easier to architect and much more scalable. And the baseline architecture that I use is this. And this is actually the reference architecture is provided in an AWS workshop. It's called AWS Serverless Workshop. You can find this on GitHub. And it's called Wild Rides. The Wild Rides workshop is actually a fake application which talks about how you can get a ride on a unicorn. It has some fun aspects to it, but the architecture is real. The workshop also provides you with detailed documentation on the architecture as well as a CloudFormation template. All right, so this has three pieces. It uses S3, Cognito, API Gateway, Lambda, and DynamoDB. We will be delving a little. Let's dive a little deeper on each part. All right, the first piece is the static files. Your application is going to have static files like JavaScript, HTML, images, and so on, and even index.html files. The files can be stored in S3. As you know, S3 is a serverless service. It's not a block storage. It's an object storage service, and again, you don't worry about the number of instances that you have. And S3 can also be used to host a static website, and that's what it's shown in this picture. And when the user hits the web browser and points to this application URL, the files are actually being provided by from S3, right? So once this is done, you would have all the static files rendered. But then that's not sufficient because this VOC application is usually highly secure. You don't want this to be public information. So you need some kind of authentication. The service that I would use there is a Cognito, Amazon Cognito. Cognito is an authentication service. This is not the same as IAM or Identity and Access Management Service. That's a different service. Cognito is a serverless service which lets you create users in an application. For example, if you've built an application, I've built an application where you have a sign-in or a sign-up page where people register, provide their first name, last name, and their email address, and provide a password, and then it would send back an email, a verification email to your email address inbox, and then you would click a link, and that would authenticate or that would validate your account. And then once after that, you would be able to access your account. All these are part and parcel of Amazon Cognito. It's very customizable. It's very easy to use. It provides you MFA or multi-factor authentication and all the good stuff, right? So that's a very easy way to have a scalable serverless authentication piece module added to your application. Once you have that, customers would be logging in using Amazon Cognito. It would, once you authenticate it successfully, it would provide a JWT or a Java Web Token. And using this, you'd be able to access the next step. That is, the next step would be when a customer, we provided static files, now we have authentication. Now let's say you want to have some dynamic processing. And the serverless architecture for that is the AWS Lambda. So what we previously saw was S3, and that's for object storage, and then we saw Cognito. Now we are looking at AWS Lambda. This is a computational unit, but it's still serverless. The AWS Lambda lets you run a piece of code, and it executes a function. And once the function is executed, it goes away, it disappears. And then you are going to be charged by the number of times this piece of code is executed, not by the number of hours you run an instance. So that's what makes it serverless. And this is the centerpiece of being a serverless architecture. So the user makes a call, triggers a Lambda function. The Lambda function, you can write code in Python or a Node or even Java, and it supports any number of languages. You can look up the documentation. My favorite is Python. So in Python, I would just import a library called Boto. That is a library to access other AWS services. And in here, the example that I have is DynamoDB. This is a serverless NoSQL database. So in this example, the customer is providing some information, providing feedback, and I'm going to be writing. I'm going to get this JSON in my parses JSON in my Lambda function, then make a call to DynamoDB to insert this into the database. Once it is completed, I return back a success. Right. So that is a small piece of the architecture, and that's when we piece this together. Now we have the part where the customer provides feedback, and that is inserted into the data store. So this is the collect part of the application, right? So this provides the base level architecture of how you would architect this. The important piece that I left out here is the API gateway. Users cannot directly trigger Lambda functions. You don't want that. Lambda functions are triggered using Amazon API gateway. An API gateway is which receives RESTful request, a REST API call or HTTP request, and you can point that to do a certain number of things. And you can have API gateway trigger a certain Lambda function, and that Lambda function performs a function. And then once it's done, you can do this. A single API gateway can trigger multiple Lambda functions, and so on, as you will be seeing this extensively in this architecture, in this webinar. All right, now let's see, now that we have a baseline architecture, let's see how we can enhance this using NLP. All right, we have quite a few services that we can use to enhance this application. Let's talk about how and AWS has over 100 services. So let's see how we can split these and understand these, categorize these services to help us get a hand around this. Right? So I look at this picture and I see three layers, right? The bottom layer is about frameworks and interfaces. The middle layer is platform services, and the top layer is application services. The bottom layer talks about frameworks, and this is the core of this is the Amazon Deep Learning Army. The Deep Learning Army comes packaged with the most popular deep learning libraries, like frameworks like TensorFlow, MXNet, and so on. But in this architecture we will not be using this, because that would make it not a serverless architecture, because it will be spinning up instances. We will not be using that. The next layer is the platform services. A platform is where you have certain things put together for you, but it lets you create your own models, right? So Amazon SageMaker is the centerpiece of Amazon machine learning on AWS. And on top of that is you have application services, and you have computer vision services like Amazon Recognition, and onto the right, as we marked with a dark boundary, we have language services like Comprehend, Lex, Poly, Translate, and Transcribe. And Amazon Comprehend is the main natural language processing service that we will be using. And one important thing to notice in this top layer is these are application services. That is, you use these services by making an API call, but you are not building your own models here, right? You're just making use of already the models that are built within the service. All right. Now let's look at how we can bring those services into this architecture. So as we saw, you have a user is making a RESTful call saying that, hey, I want to provide this feedback, right? They fill out a form, HTML form, they push a button that says submit. The JavaScript takes this and does a HTTP post. The post goes to the API gateway, and it receives this on, let's say, feedback.html, right? And in this resource, it takes this post, and I'm going to configure the API gateway to invoke a Lambda function. The Lambda function is invoked, and it receives this input in JSON, It parses this JSON, finds the name of the user, name of the customer, and the feedback that's provided and other details. And once it then calls imports Bodo. That is the Python library that is going to help me insert this into the DynamoDB database. Right? Once this is done, this is the collect part that we already saw. The next part is now I want, once this is done, the second part is now the user comes in, that is an internal user, the product manager or upper management. Now they want to run a certain NLP service, right? And I want to understand the sentiment of all the feedback that I have. So it's going to say this person is going to log in and say get sentiment, right? Now this is going to go into API gateway. It's going to call a different Lambda function. And in that Lambda function, again, I'm going to import Bodo. Now I'm going to make a call to comprehend. The comprehend is an NLP service. It provides a bunch of NLP services like sentiment, topic modeling, and so on. And once that is done, that is going to help me get the sentiment of all the feedback and insert it into a DynamoDB table and return. And let's say I'm a person, if you're like me, I only know how to read and write English. I do not know how to read and write any European language or Chinese. But let's say your customers have provided some feedback in Chinese, which I cannot read. So what you do is now you can say, hey, please help me translate these. So you push a button, say translate. Now this is going to invoke a different Lambda function. And you send make an API call to Amazon Translate, and this Amazon Translate takes this text, identifies the language, and it also knows, you tell it which language to translate to. Let's say you want it to, the target language to be English, so it translates this, sends it back as a text, and that is going to be inserted into a DynamoDB table again for future storage. And once you've done, now you have some idea of what is going on. You can read the text, but let's assume that you have a large number of feedback. Now you want to run your own specialized kind of classification on this. You want to understand, you want to build your own model on top of what you already have seen in Comprehend and Translate. This is a custom model that that supports your business case. So what we have is we have Amazon SageMaker, which helps you build your own models, take this data, build your own models, deploy this as an endpoint. And again, once you've deployed it, you use Lambda to call this API endpoint. In SageMaker, it makes its own prediction. You then insert it back to Dynamo. So as you've seen, you can use any of these or all of these services to enhance your application. Now let's look a little deeper into sentiment analysis or comprehend. Right? What is sentiment analysis? Sentiment analysis is an emotion that a person has when that person writes a sentence, right? And they try to communicate that sentiment through that sentence. For example, if I say I love my country, that is a positive sentiment. Whereas I hate the flu, it is a negative sentiment. Obviously, this is easy to understand because of the keywords here, love and hate. It's not always as simple because you could have complex sentences. So you could say, I love to hate a movie, and these things makes it more complex. And so that is why NLP is a hard problem, right? Why is NLP hard? NLP is hard because you need to have, it's not straightforward. You need to have a large corpus of data to train. Usually goes into the petabyte size. And then you need to have annotated data. What do you mean annotated data is if you're looking at classification problem like sentiment analysis, you need to have data that says, hey, this sentence is positive and this sentence is negative. I need to have millions of those annotated data sets. Right? That's what we need to build a supervised model. And then you need to have an NLP model that is sufficiently complex enough to to understand the complexity of your problem. And the last is the training the model. The training the model usually involves GPUs, so that could take a long time, and you might want to fine-tune your model for a use case. So these things make NLP problems really hard, right? And enter Amazon Comprehend. This is a primary service which helps you do 5 different things. It helps you identify the sentiment, right? It can identify entities in your sentence. For example, in my previous sentence, I had "I love my country," so the entity there would be country. Country is an entity. It can identify languages, English and French. It can differentiate between that. It cannot translate. We have a different service for that. But this can identify languages. It can identify key phrases, and it can also do topic modeling. We'll look briefly into what each can do, and this is all powered by deep learning. All right. So given a sentence like this, Amazon.com is located in Seattle, was founded by in July 5th, blah, blah, blah. The named entities here are Amazon.com, organization, Seattle. As you can see, these have been identified by the service. It can also identify key phrases like "our customers," "great prices," and so on. The sentiment there is generally positive, and the language is English. These are things it can identify, right? What is topic modeling is a little different. What is topic modeling? Let's say you have a large piece of text. You have several documents, and some documents, let's say it's all medical documentation. Let's say some documents talk about a flu, the influenza, the effect of population, and so on. You can identify the bunch of a set of words that can cluster together and is about a specific topic. And what it does is, so you give a bunch of documents, it's going to identify the topics that are present in these documents, and then identify the topics that are present in these documents. For example, the first one has topic number 0, the proportion is 0.89, and in the topic number 1 is only 0.67, and so on. So topic modeling helps you classify or cluster your feedback in a certain way. So this can be used in your VOC application as well. Let's say you have multiple product lines and you have feedback. You could run topic modeling to understand whether what kinds of problems are they talking about. Maybe in my previous company there were always some feedback about UI. Problems with some UI and some problems with licensing, right? And so with topic modeling, you would be able to separate these out and identify the high-level topics in these feedback and attack this in a certain way, right? So now, how do you invoke comprehend? It's very simple. This is a Lambda code. As you can see, it is just like 4 lines of code. I'm going to import Boto3. This is Python, by the way. Import Boto3 and import JSON. These are 2 libraries that I need, and I'm just calling Boto3.client. The service name is comprehend in a region. It's going to give me a comprehend object, and then I'm defining a function, the Lambda handler. This is the entry point for the Lambda function. Just 4 lines here. I'm going to format an input called review. Review is the text that is coming in. I'm going to get that into text. And then I'm going to make a JSON.dumps I'm going to make a call to comprehend.detect sentiment. I'm going to pass this text and then specify the language as English and a few more parameters. This is going to give me JSON. I'm going to load JSON into this, load the string into JSON. And I'm only looking for the sentiment. So sentiment is one of the tags in the JSON, and the sentiment could either be positive or negative. I only have 2 values. I'm going to return this. You can run this code and insert your own text and find out what the sentiments are, right? So that is the sample code. This can also be done in Java. Again, it's only just 4 lines. The first line talks about creating a client. The second line is defining a text, like "I love Seattle, today is Sunday," blah, blah. And the third line is making this call, batch detect entities, and I'm passing this list of text and making this batch entities. And the last line is just a for loop. That's going to print out what result we got for each of this text. So it's fairly simple. If you're familiar with Boto, this is even simpler, right? Now let's look at how this can be used to enhance your VOC application, right? I have a bunch of feedback from my customers. Now, for the first thing I want to do is sentiment, right? I want to see if my customers are exuberant about my product or not so happy about my product. So I'm going to run using Amazon Comprehend, get the sentiment. Next thing is I want to understand entities they're talking about, right? So entity recognition is identify the entities in the sentences. So this I could use to identify the products that they're talking about, because let's say you might a customer enterprise could have multiple products. In my previous company, we had close to 100 products, and this would help me understand, classify which products that they're talking about. Then that would help me slice and dice this data much better, right? And the next thing you could do is topic modeling. Like I said before, in my previous company, in the VOC application that I developed, there were always some feedback about UI and enhancements to UI, and there were some about licensing, right? So these were two clusters of problems that the customers were talking about, and topic modeling could help you do that, right? It's going to say, identify that, hey, these are all the feedback documents that are talking about UI. These are all the things that are the feedback that is going to be that is talking about the licensing or any other issue. So it's going to bucket them into these buckets, into these topics, and provide you that cluster. So that's very useful, right? Now, let's say these are all provided by Comprehend, but now let's say you want to go one level further. You want to build your own classifier or some sort of machine learning algorithm on top of this. So that's where SageMaker comes in. SageMaker is a centerpiece of our machine learning platform, where you can build your own models. You can bring your own data, build models, and deploy. So it's an end-to-end machine learning platform, zero setup. We have most of the common popular software packages available for you to use, and you pay by the second, right? So 3 steps here. The first step is build, where you provide notebook instances, and you create your own Python scripts or Jupyter notebooks. You can optimize your models. And the second step is build your models, and the third step is to deploy these models. Right. So let's look at the more detailed process, step-by-step process of how you do it in SageMaker. So first, obviously, you start with a business problem. In this case, let's say in your VOC application, you want to identify the gender of the person, of the customer who's providing you feedback. Right. This may be important. Let's say you are a clothing retailer, and you're selling clothes. You want to understand how gender is impacting the feedback, or you want to understand if men like this more than others. So that's a custom classifier that you're building, and that is the business problem here. Identify the gender of the customer. So once you have that, now you've framed it into ML problem. Now this is a classification problem, and the data set that you're going to use is probably the name of the customer, right? So once you have that, now you start collecting data. You need this is a supervised learning model. You need data. You need to have lots of data to train, and you collect the data. You integrate it with whatever data you already have. You probably also want to clean the data to remove any noise in there. Once you do that, then you do the feature engineering. One example is you want to understand whether you want to use the first name or the last name, or combine them both to identify the gender, and so on. And then you train your model, you fine-tune the model and improve accuracy. So if your goals are met, you continue. If it's not met, you go back and start collecting more data or different kinds of data. But once you're happy, with the model that you built, you deploy the model, which you do through SageMaker, which makes it a very seamless process. Then you start, you get an endpoint just like how you have with Comprehend, and once you have that, you're done. But you continue to monitor the accuracy and the kinds of data that you have. You keep adding the data to new data that you get to the data collection that you already have, and you continue this process. So this is the machine learning process and how you would use SageMaker for this, right? So the last step is, once you created this model and deployed it, it's the same story here, right? You have this API gateway, you trigger this Lambda function. Now the Lambda function, configure the Lambda function to use the API endpoint that was provided by SageMaker. After you deploy the model, insert that in the Lambda function. It's going to make the call to Amazon SageMaker and insert the results back to DynamoDB, right? That is That is pretty much the architecture. It now I've shown you like how to improve or enhance your architecture using several of the features of Comprehend and SageMaker and Translate. Right now, an architectural discussion is not complete ever without an understanding of the pricing. Right. So let's look at the pricing in this. The first level, first item here I have is Lambda. Lambda is charged. You are charged by the number of times you invoke. It also has a free tier, which is 1 million invocations free per month. But I'm not talking about the free tier here. Let's say it's going beyond the free tier, and I'm going to assume that the application runs on 1 million sentences in a month. And the Lambda function is this micro unit. So I multiply that by a million, and I have $16. And the API gateway usage, it comes to around $3.5 per month. S3 is 0.02 or 2.4 cents per GB. I'm going to assume it's going to take a GB to store 1 million sentences. That comes to around 0.02. And comprehend is per unit, and that comes to around $100. And the last is the DynamoDB, the database store. That comes to around 81 cents per month. And the total for this whole month comes to around $121. Right? If you notice, the biggest cost here is Comprehend. That's because it's a deep learning service. It uses GPUs and so on. But the Comprehend is used only once on a sentence, right? So let's say you have a text and you want to run Comprehend. You call an API call, make an API call, and once you get the result, you store it in DynamoDB. So you are not going to be running this through Comprehend on a monthly basis, right? So once you have a text that's passed through Comprehend, you're done with it, right? You're not going to be, it's not a reusable, it's not a recurring charge unless you have a million more sentences the next month. So the cost of this comes to around $121 and on a realistic scale. So that's a huge saving when you use the serverless model and you use the AWS services Comprehend. I did not include SageMaker into this because it's hard to evaluate how much of a usage SageMaker could have because it really depends on the use case. But SageMaker usage is also one time, where once you build a model, it's going to be just deployed, right? So you can add that to this list. But estimate here comes to around $121 per month, right? So that is your architecture that's based on a serverless architecture, and we saw how you enhanced voice of the customer application using NLP techniques, especially using Amazon Comprehend. So for more details, you can look at aws.amazon.com/comprehend. Thank you.